Hi, I hope this video finds you well. Today we are addressing LeetCode number 128, longest consecutive sequence. Given an unsorted array of integers that we're calling nums, return the length of the longest consecutive elements sequence. And the algorithm must run in O of n, or linear time. So we're given this array and our output is 4. So how is this the case? Well, clearly in the nums array that we've been provided as a parameter, um, we are we can sort of decompose this array into three distinct sequences. So 1, 2, 3, 4 is sort of a sequence of consecutive elements. And then 100 and 200 are sequences of their own. And so of these three sequences, we can see that the longest sequence is 1, 2, 3, 4, and therefore 4 is the answer. In this example 2, we can clearly see that we have multiple sequences. In fact, we can pick and choose, right? So like, 2, 3, 4, and 5 it could be a sequence. 2 and 3 could be a sequence, but the longest sequence would be if you started from 0 and you built your way up to 8, in which case you would have 9 members of that sequence, making 9 the longest consecutive sequence. In terms of amount, the longest consecutive sequence is actually, of course, each member that contributes to that sequence, but the numerical amount of how many members that sequence holds is 9, and therefore that is our answer. So the way that we're actually going to solve this problem is we're essentially going to put all of these elements into a set. And the idea behind that is that will allow us to iterate through the array one by one. And then for each element, we can ask, can we subtract 1 from the number that we're looking at in any given iteration? And if that number exists, then it is not the beginning of the sequence. So our first step is to find the beginning of the sequence and then work our way up, constantly add 1 to that number, which would in effect allow us to basically move through that sequence. So the first step is, iterate through the array, look at each element, subtract 1 from it iteratively, and ask, does this number exist after having subtracted 1 from that number? If it doesn't, well, then there's no number you can take 1 away from it and get that smaller number. So that would in effect mean that you found the beginning of the sequence. Like if I'm over here and I say 3, 3 minus 1 is 2, does 2 exist in the set? We will get a positive Boolean value of true for that. And so 3 is not the beginning of the sequence. If we do the same thing for 2, we would get false for that, right? I mean, in the sense that a smaller number does exist in the set, which is 1. And then when we do that for 1, can we subtract 1 from 1 and get that number? Does that exist in the set? If it doesn't, we know it's the beginning of the sequence. And then once we find the beginning of the sequence, we're going to have a counter that will basically open up another loop that will basically say, okay, well, while we can still add 1 to the number and work our way up, keep incrementing that counter. That will be the length of the sequence. And then we'll store that into a maximum, or we will maximize that really. So I mentioned a set several times, and so we're going to introduce a set here. And the idea is that once we've established this this set here, we're essentially going to open up a for loop. So for int I is equal to 0, I is less than nums.length. And once we've opened this for loop up, we can basically say, well, as we're looking at each element, if any nums of I minus 1, so this is we're going to ask ourselves, does nums of I minus 1 exist in the set? Can we subtract 1 from any particular number? And if that number doesn't exist, well, then we know it's the beginning. So we're going to basically put this whole thing in a set.contains. And so we're going to say, okay, well, can I do nums of I minus 1? When I do that, is that contained in the set? So if the set doesn't contain nums of I minus 1, then we know that the nums of I we have on hand, the nums of I we have on hand is the beginning of the sequence. So we can actually store that here. We can say beginning of sequence is nums of I right now. Okay. And then we're going to we're going to introduce a length variable that's going to allow us to keep track of the length of a particular sequence. So int length is equal to 1 because we found one member of the sequence. So that should be included in the length as we increment it. And we're going to say, okay, well, while the set dot contains, so while we can take the beginning of the sequence and add 1 to it, well, we'll keep incrementing the length. So there's going to come a time where we can't add 1 to the beginning of the sequence, and that won't be contained in the map, right? Because if you're at 1, well, we can add 1 to the beginning of the sequence and get 2. Then we're now at 2, so we're going to increment beginning of sequence. We're now at 2, and then we're gonna come up here. We're gonna say, okay, does the set contain beginning of this? Now beginning of the sequence is 2, but it's not actually beginning of sequence, but it's really it's storing 2, right? So can we take 2 and then add 1 to it? Is that contained in the map? And it is. We get 3, and then we move up to 3 now. All right, and then we ask, okay, well, can we add 1 to 3 and get, is that in the set? And yeah, it is in the set. We have 4, and then we add 1 to 3 and then we get 4. Now we're asking the same question for 4. Can we add 1 to 4 and get is that in the set? And clearly in this case it's not. And so we've been keeping track of length as we do that. And so length is actually, it reflects the sequence as we've built the sequence up, counting it at each time. And so what you want to do later on is you want to say, okay, well, I'm going to introduce an answer variable. And answer, if the length that's just been calculated is greater than the answer, then the answer should be treated as the length that we have right now. And then we're just going to return answer. Another way of doing this, you could say answer is equal to math.max. The length that we answer what it was before. It's going to be the maximum between what the answer was before or the new length rather. Each of these are fine. So okay, let's see what went wrong here. So let's see. Remember how I said we actually want to add all the elements into the set. And so basically in order to do that, we would basically go through the set and just do set.add n. This is one way of adding all the elements into a set using what's often called an enhanced for loop. And it seems as though that doesn't really solve the problem either. So we're going to have to do, let's see, so we're going to have to try to guess what else could be wrong. Is it the case if I use this way of finding the max? Although both of these really mean the same thing, so it isn't the case that this should make a big difference here. We actually want to iterate through nums instead of the set, as it were. We're trying to grab numbers from nums and not really the set. And so that should be an answer here. But of course, the efficiency is kind of low. And so if you actually iterate through the set instead, you can increase your efficiency. So if I say 4 and then I'll call it element in the set. So now I'm actually iterating through the set instead of the for loop. And what we can see here, if we make the appropriate changes, is that we actually increase our overall efficiency. So so we get closer to a more efficient answer. And as I was saying here, if the length that we calculate by going through this process, if the length that we calculate is greater than what was previously stored in the answer, then the answer should be treated as that specific length that is greater, since we're trying to maximize. And so we have a better efficiency in that sense. And so that's essentially the idea behind longest consecutive sequence.